Let's look at one more example. Example 3. Suppose that the instant runoff method is used in an election and the preference schedule shown below gives the ranked voting results. So this time we're going to evaluate instant runoff for this particular election. So we always have to start before we can critique an election method or a voting method. We have to first think about who would win with that voting method. So who wins this election? Well, with instant voting, we start by looking at the first choice votes for the 3 candidates in this case. So if we look at first choice votes for the 3 candidates, A has 11 votes, B actually has 14, and C has 10. Now, no one right now has more than half the votes. The votes are pretty evenly split. B has a little bit more, A has the second most, C has the least. How instant runoff works is that we eliminate the candidate that has the least votes and we do a runoff between the other 2 candidates. So A and B go into a runoff. They keep the votes they had originally, but we redistribute C's 10 votes. So if C is out of the race, that means C's 10 votes would go to A according to the preference schedule. Those 10 people would get their second choice for A. So we add 10 votes to A's total, and we get 21 votes for A. B has 14. You can clearly see now that A has a majority of the votes, so A wins the election. All right, so now let's analyze this scenario. Let's do a what if. Say before the election results are verified, a new election is held, and 5 of the voters who originally chose as their order B, A, and C switch their votes to rank A highest. Maybe they heard through the grapevine that A was actually winning in the election because we know when A was winning. Remember, the election results were probably known but not yet verified. So these 5 voters, maybe they want to be part of the winning team. They're like, well, I had A as my second choice, but since I think A is going to win, I'm going to change and rank A higher. Okay, so let's examine if those 5 people, and only those 5 people changing their votes so that the winner is actually ranked higher in their preferences, would we still get the same candidate winning? Well, let me come back up to this preference schedule and let's think about how this preference schedule is going to change. These people that voted B, A, and C were in a particular location in the table. They were in this 3rd column. They were part of this group of 6. So when their votes change, they're going to end up going into a different column. In particular, if you think about it, those 5 people, their votes are going to end up going over into the ABC column because they're going to have A ranked highest. They want to kind of be part of the winning team, as I said. So it can be a little confusing to see it on the same preference schedule. Let's redraw the preference schedule to kind of show what would happen. So I still have first choice, second choice, third choice here. And I still have the first group of people ranking A, B, C. We have the second group of people ranking B, C, A. We have the third group of people B, A, C. And we had our fourth group of people who ranked C, A, B. Now, really what's changing are only 2 of the columns. The 2 columns that are going to change are the one where those voters were who are changing their votes, and then the column that they're actually going to now be a part of. So we're going to have them splitting into 2 columns. Those 6 votes split into 2. We're going to have 5 people move over into the first column with the people who voted for the winner, and then 1 person out of that 6 says, nope, I hold by my original vote preference that B is my first candidate, A is my second choice, C is my third choice. Now, the 10 people in the third column didn't change. The 8 people in the second column, they didn't change their votes. But again, those 11 people are now joined by 5, so we have 16 in the first column voting for A, B, and C. So my preference schedule changes because those 5 people changed their rankings. Now, let's redo the election with this new preference schedule. First off, looking at first choice votes, we now have A getting 16 first choice votes, B now getting 9, and C getting 10. Now, no one yet has a majority, so this is where we would do a runoff. But the instant runoff says eliminate the voter or the candidate that has the least votes. B now has the least votes and gets eliminated. So A keeps their 16, C keeps their 10, and we have to figure out whose votes B would go to. Well, B got 8 votes from the second column, and those 8 people their second choice would be C. So 8 people switch over to C, and then B got 1 of the 9 votes from the third column, and that person would switch their vote to A, candidate A. So when I do the new tally, A now has 17 votes, C has 18 votes, and now we see that C has the majority, so C wins. So we have this kind of maybe unintended consequence. These 5 voters, they wanted to switch their rankings to actually rank the winner higher, so maybe being on the winning team, and what happened is inadvertently, because of how the other numbers came out, they end up causing someone else to win the election. Their votes, by transferring their preferences, they actually weakened candidate A and actually, well, they initially made candidate A stronger, but they weakened B and caused B to fall out, which then made C stronger and C won. So this is kind of an unusual event, and it is a what if, but it would be considered an unfair situation that ranking someone higher who you know is going to win shouldn't cause them to lose. Ranking someone higher shouldn't cause them to lose. So this is a violation of the fairness criterion, and that's the last criterion that I had listed on that first slide, what we call the monotonicity criterion. The monotonicity criterion here is violated because you have a different winner when a few of the voters switch their preferences to actually vote the original winner higher. So what we've seen is that board account for a particular election has failed the fairness criteria. We have instant runoff for a particular election that has failed the fairness criterion, and we have plurality that has failed the fairness criterion. You might start asking yourselves, well, is anything fair? Well, I want to remind you that lots of elections are fair. When we look at fairness criterion, we look at a particular election and whether that election is fair for that voting method. Lots of elections are just fine. I kind of focused on ones that weren't. But you will always, it turns out, have a particular election that might not work for one of these voting methods. In fact, it was proven by a particular mathematician, Arrow, that, and we call this Arrow's impossibility theorem, that no election method will be fair for all possible elections. In other words, there will always be, there's always a particular election you can find that a particular voting method will fail a fairness criterion for. So, no voting system is fair in all cases. And I should say for 3 or more candidates. Because remember we said that for 2 candidates, plurality and majority, therefore, are the best way to go. It's just simple with 2 candidates, look at who gets the majority of the votes. But no voting system is fair in all cases. Again, it can be fair for lots of cases, but when you look at all possible cases, all possible numbers that could come up in an election, no voting system will be fair.